Hello and welcome. We're starting this topics discussion, objects number 2, so the second half of objects, on this idea of composition and has-a relationships. So things we've said before, we've kind of laid out the different things that we know different objects might have. Let's take a look here at a box that we're going to pretend is a car. I'm going to even run out of room if I put the word car in there. I think I wrote box, didn't I? Whatever. So this is a car, and we can ask ourselves, what does a car have? And we know a car has an engine, and a car has some number of, it's going to be real tiny to write wheels here, some number of wheels, right? If we imagine for a second that we have a library, we ask ourselves, what does a library have? Well, a library might have, a bunch of books. And there might even be a name on the library. Library probably has a name. It's not just called library, right? This idea of has-a, what do each of these objects have? What are they composed of? Is the idea of composition. There we go. So composition basically means that one object is made up of other objects. A car would not work without an engine. It can't go anywhere without wheels, right? A library wouldn't be very much of anything if it didn't have a bunch of books inside of it. This is the idea of composition, bigger things built out of smaller things. Okay, so if we're looking for another kind of definition here, we could even say objects built out of objects. Right? This is objects inside objects. There we go. Now, what we've seen so far is we have seen like a book that has a string title and a string author and an int number of pages. Or we've seen a car with an int number of wheels and a string color. While capital S string is an object, so technically we have seen some form of composition, we can take it one step further and we can design our own composition. So in Java, we can show this by declaring object fields inside of a class, right? So this means our class will contain an object as part of its design. So imagine we have a class engine, and it's going to have its own fields and methods, whatever they might be. And then we also have a class car, and internally it has a private engine. This is the data type. This is our object field, right? That is an object field. That is exactly what this is. So we can now use it in our constructor and beyond. More code, more car class code. There we go. Okay. So we have different ways of representing objects in a visual manner, right? So here I've drawn some for you using boxes, and here I've written some code out for you using it's pseudocode, but the idea of code sort of is true either way. There is another way to do this that are known as UML diagrams. UML stands for Unified Modeling Language, just if you're interested. And they help software developers, architects, business teams, really anybody who has some sort of invested interest in this project and how it's being implemented to document everything and sort of understand the internal workings of an application and the workflow as well. So So when we start talking about these UML diagrams and ways to sort of draw out what is expected of our code, we could draw it this way. Whoops, I didn't mean to erase that. We could draw it this way, but really this could get very messy for very complex large objects. So we use these diagrams instead. And when you want to do when you want to show off sort of this composition relationship, so the composition or has a relationship, this is going to be depicted with a diamond. And yes, there are other types of code relationships and object relationships, but right now this is the one that we're focusing on. So what this actually means is when we want to draw out the relationship, actually these two boxes are kind of close together there. The relationship between two classes and how we can draw this out is in our diagram, we sort of box all of the different classes that we might be using, that we might have in our project, and then we draw arrows between them to depict this relationship. Now, when I say we want to depict this composition relationship, what that means is that the engine is inside of the car. We put the diamond on this side. So the diamond being on this side means car is composed of engine. That's what that relationship drawing actually means. And there are other sort of symbols and drawings that we could be using. But again, we're just focusing in right now on this idea of the has a relationship and how we would depict that. So if we had also a person, let's say a person class right there, and a person might have a car. So we might be able to associate a given car with a person. We would have to do the same thing. We would have to draw that exact same relationship, only now the diamond is over here because the person has a car. And maybe also in this situation, the person has a bank account so that they can afford to buy the car. So now a person with that diamond also has, it's not a great diamond, but here we are. A person also has a bank account. And we can see how this picture can start to sort of take shape. Now, usually we would create, when it comes to actually like initializing something like this, we would do so inside of our constructor, right? We would want to make sure that it happens inside the constructor. And a common mistake is letting outside code mess with that inner object directly. And we talked a lot about this during our access modifier video as well. We want to make sure that our code isn't going to sort of have those encapsulation issues. So how is it that we want to be able to write this out? And we'll keep talking about this. This is going to be a common theme throughout. If we have an engine class, let's imagine that an engine has a horsepower, int horsepower, and this is going to have getters and setters as required, getters or setters as needed. Great, that is our engine class. That says engline. I don't know what happened there. There we go, engine. I have no idea. Oops. I have absolutely no idea what just happened with that wording, but that's okay. Such is life. Then we're going to have our class car. And we would say private engine, spelled correctly this time. Eng maybe. We would have our constructor. Maybe it doesn't take anything in right now, but we can create our engine. So eng is equal to a new engine. And what you'll notice is that I cannot say, I'm going to do this in red because I cannot say eng dot horsepower. Right? That's not going to work, equals whatever. This does not work because our eng is private. The horsepower variable in there is private. We're hiding things away appropriately. If we have our main class, public class main, and we have public static void main with our on-brand parameters, we make a new car. Car C is equal to a new car. You'll notice that we cannot say C.engine.horsepower. We already knew we couldn't say C.engine, but now we cannot say C.engine.horsepower either. Even if this was public, we might be, I better do that in a different color. Even if this was public, we could say C.eng, but we would still not be able to say .horsepower. Right? We can see how those accessibility modifiers might start chain reaction. The different ways in which we use them may start some kind of a chain reaction there. So this idea of composition is how we build complex systems out of smaller ones, right? HAZA is that composition. So if we hear ourselves saying, well, it has an engine, that tells us we want to use composition. And in our UML diagrams, we want to make sure that we're looking for that diagram that has a diamond. So then that way, if I gave you this diagram, you would be able to actually reproduce the code for me. It's always a great exam question. With that, I will wrap up this description of this HAZA relationship. And our next conversation is going to focus in instead on the keywords static and final and how we use those in our objects, in our user-made objects. Thanks, everybody, and have a great day. Bye.